Hi everyone! Today let's talk about session 4.8, negative binomial distribution. So let's review what is binomial distribution. So for binomial distribution, okay, we're talking about case success and trials. Okay, so for the pictures, we have M boxes, and we want to pick K of them to fill with success, right? And then the rest are failures. Okay, so that's why the probability X equals to K is we have M boxes. K of them are success, right? Okay, and the probability of success is P, so we have K success, and we have M minus K failures. Okay, so we have K success and M minus K failures. That is for binomial distribution. Okay, how about geometric distribution? So for geometric distribution, okay, so we care about first success in the cave trials. Okay, so in this case, the number of success is fixed, that's 1, and the number of trials it varies, right? So it could be 1, it could be 2, it could be so big, okay? So unlike the binomial distribution, in the binomial distribution, the number of success varies. The number of trials is fixed, okay? And for geometric distribution, what's the picture? So here we know the last one is the first success. Okay, so this is the first success this is in the cave trials. So it means all of the previous one are failures. So here we have what? We have K minus 1 failures. Okay, that's why the probability is we have failure, the probability of failure is 1 minus P, and we have K minus 1 failures, and the last one is success. The probability of success is P. So this is the PMF for the geometric distribution. So today we're going to talk about negative binomial distribution. So what is negative binomial distribution? Okay, so geometric distribution, we're talking about the first success in the cave trials. How about when we want to ask the F success in the cave trials? So if we want to draw the picture, what color do you like? Do you like pink? Okay, so if we want to draw the picture, it means, okay, this is the boxes, and okay. Alright, so we know the last one is success, and we know this is the F success in the cave trials. So it means how many success in the previous trials. So first of all, how many previous trials are there? So the last one is the cave trial. So the previous one, we have K minus 1 trials. And how many success are there? The last success is the off one. So in the K minus 1 previous trials, we have R minus 1 success. Okay, does that like binomial distribution? We have K minus 1 trials, and we want to fill with R minus 1 success there. So here we have R minus 1 success, okay, and the rest are failures. That's why the probability of success in the cave trials. So in this case, K varies, and the R is fixed. Okay, it's like the geometric distribution. We have the first success in the cave trials. The number of success is fixed, and then the number of trials varies. Okay, so K varies, and the 1 is fixed. Okay, so see, in the previous we have K minus 1 trials, and we have R minus 1 success. That's why we have K minus 1 choose P minus 1. And then the total, what's the total number of success? The total number is we have K successes. Okay, and what is the total number of failures? Well, the total number of trials is K, is the number E? Oh, sorry, I have a typo here. So we don't have K success. The total number of trials is K, and we have R success. So this is not K, this is R. Okay, and how many failures? So the total number of trials is K, and we have R success. That's why we have K minus R failures. Okay, so this is the formula for negative binomial distribution. Okay, so definition. Let P be the probability of success is between 0 to 1, and let R, so R is fixed. Given R in is a real number, is a natural number, a random variable X with range R plus 1, blah, blah, blah. Okay, the PMF, the probability of X equals to K, is K minus 1 choose P minus 1 times P to the R, okay, times 1 minus P to the K minus R. Okay, so this random variable with the probability mass function, and it has the negative binomial distribution with success parameter P, and we denote X has the negative binomial distribution with the parameters R and P. Okay, we mark. First, for negative binomial distribution, you can see here well, if we look at the previous picture, okay, so if we look at the previous picture, so here for the first K minus 1 trials, so it's really like a binomial distribution, right? So that's why here we have the binomial distribution with the number of trials is K minus 1, and we have the number of success is R minus 1. And then the last one, the last trial is success. That's why you multiply by P at the end. Okay? Second remark, for the binomial distribution, we have N fixed trials, and K is the number of success. For the negative binomial distribution, we have R fixed success, so the number of success is fixed, and K is the number of trials, so K varies. Okay, so it's like for binomial, the number of trials fixed, and the number of success varies. For negative binomial distribution, it's like the opposites. We have the number of trials varies, and the number of success is fixed. Okay, so and also because the negative binomial distribution, you can see is quite related to the binomial distribution. So that's why the name is negative binomial distribution. Okay, I want to put one more remark here. The mean for the negative binomial distribution is R over P, and the variance of the negative binomial distribution is R times 1 minus P over P squared. Okay, so this is the mean and variance. So we're not going to prove that. The formula of the mean and variance for all the discrete distributions will be provided in the exam. Okay, so you don't need to memorize the formulas. You just need to know how to distinguish the different distribution and then use the correct formula. Okay, so let's look at some example. All right, example 1. An automated weight monitor can detect underfilled cans of beverage with probability P is 0.98. Find part A. It fails to detect an underfilled can for the first time when it encounters the 10th underfilled can. So, do you notice that here you can see the first, the 10th, you can see some order involved. Okay, so in this case, well, when you see some orders involved, then think about geometric distribution and the negative binomial distribution. Okay, so part A is like the first time when it encountered the 10th cans. So it's like the first success in the 10th trial. So it's like first success in the 10th trials. So in this case, we have geometric distribution. Okay? So in this case, we have the geometric distribution. Alright. So that's why the probability x equals to 10. That equals to, well, remember, we have the last one is success, so the previous one are failures. So how many boxes are there? So there are 10 boxes, and the 9 of them are failures. And then the last one is success. Okay? So that's why, what's the probability of success? Well, so in this case, the probability of success is, so let's see, it fails to detect. Okay, so let's say success is fail to detect. Okay, then failures is actually, it detects. Okay, so the probability of failures is actually the probability it can detect the underfilled cans. So the probability of it can detect the underfilled cans is 0.98. So sometimes you have to read the problem carefully, okay? Because part A asks, it fails to detect the underfilled can for the first time when it encountered the 10th underfilled can. So success is fail to detect. Okay, so that's why the last one, fail to detect, is 1 minus 0.98, which is 0.02. Right? Okay, so plug this in your calculator. You get approximately equals to 0.0166. 7. Okay, so usually please keep your answers in 4 decimal places, but if you see more zeros here, keep 4 significant figures. Okay, all right, so part B, can you pause the video and try to work on part B? All right, are you done? Let's continue. The 20th underfilled can is the second. So you see second and 20th. When you see the order, think about geometric distribution or the negative binomial distribution. So in this case, it's like, oh, the second success in this 20th trial. Okay, so that is why if it's not first, if it's second, then we have the negative binomial distribution. Okay, and here, what is R? R is, so remember R is the number of success, and K is the number of trials. Let me ask you, R and K, which one is bigger? Yeah, R is the number of success. K is the number of trials. Which one is bigger? Of course, the number of trial is bigger, right? Suppose, yeah, let's say we flip the coins, okay? If I get head, I win. Can we have like 5 heads in 2 flips? No, the number of trials must be bigger than the number of success, right? That's why 2 and 20, the smaller number must be the number of success. So that is 2. And then 20 must be the number of trials. Okay, so the small number is R, the bigger number is K. All right, and so we still have failed to detect is our success. So that's why the probability P of success is actually 0.02. Okay, that's fail to detect. All right, so probability X equals to K. K is 20. All right, so let's draw the picture. Okay, so the last one is success, and it's the second one. So how many success in the previous one? We have 1 success. And how many trials? We have 19 trials. So that's why the probability, we have 19 trials and we pick 1 to fill with success. The others are failures. Okay, and then look at all of them. How many total success are there? Well, with 2 success, the probability of success is 0.02, and times the probability of failure, which is 0.98. How many failures? So we have 20 trials and 2 success, so 18 failures. Okay, so 19 choose 1 is 19, and then we have 0.02 squared times 0.98 to the 18. So plug this in your calculator. Okay, so please try to plug this in your calculator. Okay, and then we got 0.00528. Do you have the same answer? Yes? Good. So for the second example, I hope that you can pause the video and try to work on it first. Okay? Are you done? Alright, so let's check our answer. A company fabricates special purpose robots, and record shows that the probability is 0.1 that one of its new robots will require repairs during confirmation tests. Find part A. The 8th robot it built in a month is the first one to require repairs. Part B. The 12th robot built in a month is the second to require repairs. Part C. The 40th robot built in a month is the 4th to require repairs. Okay. So you see, they're all orders first, 8th, so it's either geometric distribution or the negative binomial distribution. Okay? And what is success? Require repairs. Oops. Okay. Sorry, I pressed the wrong button. Okay. So, that is success. So what's the probability of success? The probability is 0.1 that one of the new robots will require repairs. Okay, so probability of A, we have the geometric distribution with the probability of success is 0.1. Okay, and we have, so the first success in the 8 trials. So X equals to 8. Alright, if you can remember the picture, we have the last one is success. Okay, the last one is success. How many failures are there? So the last one is success, and then the total is 8. So we have 7 failures. Okay, so this is what we get. Plug this in your calculator and we can get 0.04783. Do you get the same answer? Okay. Now, try part B, okay? So after you're done, we can check our answer together. Yeah, the good thing about watching the videos, you can pause at every steps and you can think more and you can practice, and then after you're done, you can play the video and then you can check the answer together with me. All right. So, we have the second success in the 12 trials. So that is negative binomial distribution. Okay, with R. Remember, R is the number of success, and that is the smaller number. Second and 12. 2 and 12. Which one is smaller? I bet you know it's 2, right? And P is still 0.1. So probably X equals to the bigger number, 12. Okay. Alright, what's the picture? The last one. Okay, the last one is the 12th one is success. Okay? And how many previous trials? So we have 11 trials, and how many success? Okay, the last one is the second success. Then so we have 1 success. So that's why we have 11 trials and we have 1 success. What's the total number of success? 2. What's the total number of failures? Well, 12 trials, 2 success. So 10 failures. Okay, so 11 choose 1 is 11 times 0.1 squared times 0.9 to the 10. Okay, so our answer is approximately equal to 0.03835. Do you have the same answer? Alright, let's continue. Part C. So the 4th robot built in a month is the 4th to require repairs. Okay, so because it's the 4th one, it's not the 1st, then it's still negative. It's still negative binomial distribution. Okay, and R, what is R? Okay, pause the video and tell me. Yes, it's 4. And P is still 0.1. So probably X equals to 40. Can you draw the picture? So the last one is the 40th and is the 4th success, okay? So which means how many trials in the previous ones? So we have 39 trials. How many success? The total is 4. Okay, the last one is success. So we have 3 successes. Okay, so that's why we have 39 trials. We choose 3 to fill with success. Oh, my S looks like B. So let's do it again. Okay. And how many, what's the total number of success? We have 4 success. So 0.1 to the 4. What is the number of failures? So total number is 40 trials. We have 4 success. So 36 failures. Okay. So 39 choose 3. That's 39. We count down. 38. 37 over 3, 2, 1. 1, we don't need to put it down. Times 0.1 to the 4 times 0.9 to the 36. Okay, plug this in your calculator. What do you get? Okay, so plug this in your calculator, and my answer is 0.02059. Do you have the same answer? All right. Let me ask you more questions. Okay, so let me ask you more questions. Okay, so find the mean and the variance for part C, okay? The distribution in part C. So in part C, we know it's negative binomial distribution with R is 4 and P is 0.1. And then for the mean, let's use the mean. The formula for the mean, what's the formula for the mean? It will be provided in the exam. So it's R over P, and our R is 4. Our P is 0.1. What is 4 over 0.1? 40. How about variance? So variance formula is R times 1 minus P over P squared. Okay? R is 4. 1 minus P, 1 minus 0.1 is 0.9. P squared, 0.1 squared. So we get 4 times 0.9 over 0.01. So plug this in your calculator. What do you get? So 4 times 0.9 divided by 0.01. Oh, the answer is equals to 360. Okay, so that's the mean and variance for part C. Okay, but if I ask you to find the mean and variance for part B, then your R will change. Okay, so for part B, the R is 2. So your mean and variance is actually depending on the two parameters, R and P. Okay, so for a problem, the probability of success is usually fixed. That's 0.1, okay, in this example. But the number of success might varies in different parts of the problem. Like in part B, our number of success is 2. In part C, the number of success is 4. So you have to read the problem carefully. Okay? So that is session 4.8. Okay? And we have finished all the chapter 4. Okay, so I will make a video later about review of chapter 4, and I can compare all the discrete distribution in that video. Okay, see you. Have a good day.